podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Services.
In this presentation, we're going to look at how to graph a system of inequalities. Some questions that you're going to need to answer. How do you create a linear inequality graph? And after you've graphed the two inequalities, what section is shaded? So we've got two equations here. Y is less than x minus 2. Notice that this is an inequality. This is less than or equal to, so this line is going to be shaded, solid, whereas this point is going to be dotted because it doesn't have the inequality sign. So let's go ahead and graph this one first. I'm going to replace this equation with 0, and I'm going to solve y is less than or equal to negative 2. So on my y line, I'm going to plot a negative 2. And then I want to pick the denominator to plug in. In this case, it's going to be y is less than or equal to (1) minus 2. Y is less than or equal to 1 minus 2 is a negative 1. So when I plug in a 1, I get out a negative 1. And that pattern is going to repeat. Got my line. Now, because this inequality is got an equal line underneath it, I'm going to make this a solid line. Y is less than or equal to x minus 2. I'm going to pick 0, 0. Is 0 less than negative 2? The answer is no, it's not. This is a false statement. So in cases when we have false statements, we're not going to shade the point side. We're going to shade the non-point side. So everything below for x. So now we're going to see which side we need to shade. Again, I want to pick a point that doesn't fall on this blue line. And I'm going to pick 0, 0 again. I'm going to substitute my y's and my x's for zeros. And see if it's a true solution or a false solution. Is 0 greater than positive 2? The answer to that is no, it's not. Because my point is here and it resulted in a false side, I'm going to shade everything on this top side. I'm going to shade it blue to make it consistent. Okay, now here's where the true statement is true on both accounts. This portion here, where both the blue color and the red coloring intermix, is the true point. So everything in this quadrant going up in this direction and going down in this direction is true. Everything else is false. It's got to be true for both inequalities. So when you're shading your work problems, find out where this information is integrated. So let's go ahead and do this one more time. These are in standard form equations. Both of these lines are going to be solid. I'm going to substitute 0 for my x and solve for my y to get rid of my x point and find my y-intercept. Negative 3y is less than or equal to 12. Remember that when we divide out by a negative, our inequality signs are going to change. So in this case, y is greater than or equal to a negative 4. So I'm going to plot my point at negative 4 on my y line. And then I'm going to do the same thing again, but replace my y with 12. Excuse me, I'm going to replace my y with 0, and I'm going to solve for x. When we do that, the y's eliminate, and we're left with 2x is less than 12, or x greater than 6. So my x line, I'm going to plot my 6. I'm going to make my line blue. And because this is equal sign there, I'm going to make sure okay, so I'm going to do the same process for the second equation. I'm going to make this one a red one. And x plus 3y is greater than or equal to negative 9. Substitute 0 for x. And we're left with 3y is greater than negative 9. Y is greater than a negative 3. On my y line, I'm going to plot a negative 3. And then I'm going to solve for x by replacing y with 0. And in this case, x is going to be greater than or equal to a negative 9. On my x line, I'm going to find negative 9. All right, now we got to figure out how to shade them. I'm going to go ahead and shade this red line first. Is 0 plus 3 times 0 greater than a negative 9? Is 0 greater than negative 9? That's a true statement. So I'm going to go ahead and shade that whole top of that red line red. And then I'm going to do 2x minus 3y is less than 12, substituting 0, 0, because I can. Is 0 minus 3 times 0 less than 12? This combines to be 0 is less than 12. Is that a true statement? And the answer to that is yes. 0 is less than 12. So again, I'm going to shade this particular section blue. And you notice that it's going to stop right here, because at this point it becomes false for the red, and everything in this top section that's integrated both red and blue is true.